All right, so this is chapter 4, section 1. We're talking about more detail about classes. We've got to remember that is a blueprint of an object. It's a model or a pattern from which objects are created. A class contains data declarations and method declarations. So we often call this instance data, because it's going to be information that each instance of that object has. We also have method declarations, which is behaviors. So the methods are behaviors or things that object can do. Functionality, right? It's going to be some function. We have several predefined classes from the Java standard class library. Strings, scanners, those are things that we've been used to using, but we didn't create them ourselves. The essence of object-oriented program development is that the process of designing and writing our own classes to suit our own specific needs. So we're trying to figure out how can we represent the things in our world that we want to incorporate into our program. So this is an example of a class that simulates a coin. We'll start up at the top. Remember, this is coin.java. This is the source code. So the source code is right here, and that is stored in coin.java. When I compile it, it's going to make coin.class. Okay, so we've seen that, and this is the Java bytecode. And that Java bytecode can be read by the Java virtual machine. That's all great. A couple things to remember is that we are always naming our classes with a capital first letter. That's the standard way to do things. It's a convention. It's not a rule. It doesn't have to be done that way, but we need to make sure that the name of our class does match our file. All right. In this example, I have 3 pieces of instance data. This is the instance data, and we have 3 variables. One that's called heads, one that's called tails, and one that's called face. So we have 3 instance data or 3 instance variables, and they represent specific characteristics of every coin that you'll ever make. I noticed that, or you might notice that they are marked, all 3 of them are marked private. That private is how we create encapsulation. So the private modifier helps with encapsulation. And 98 times out of 100, if you have instance data, I want you to mark it private. Okay, so far at the very top, we have some instance data. Next, we have this special method. This special method, public coin, notice it doesn't have a return type. No return type on this one. This is a special function called a constructor. It's actually a method called the constructor. This constructor gets called every time that we use the new keyword. So whenever we use the new keyword to create instances of coins, we're going to call this special constructor method. Its name, the method name must match the class name. So our constructor has to match the class name. And right now it doesn't have any parameters. It's just going to call the function flip. Well, you don't know what flip means yet because you've never really looked at the coin class. But the flip method you can see is defined right here. Public void flip. Well, what does that do? It sets the face to a random integer between 1 and 2, right? So actually it sets between 0 and 1. Random, 0, or 1. Well, that means that I'm setting the face. What is this variable face? Well, that is the instance data for that object. So every object that's created, when we call the constructor gets called here, which calls flip. Flip is a method that randomly generates a 1 or a 0 and stores that in the instance data named face. Okay? Perfect. That's the constructor. Notice the flip method has no return value. This one, it's just setting or updating the value of its instance data face. Okay? So it does have a return value. The return value is void. So let me do it like this here. So it does not return anything. Not return a value. So the return type is void. That's different than the constructor. The constructor had no return type at all. The flip method has a return type. It just returns nothing. Okay. The next piece of the coin class is public boolean is heads. Now this function returns a boolean, returns true or false, based on whether or not the face value is equal to heads. Heads, this all capital heads, is the constant that's saved up here. So if the face is 0, when it was randomly generated here in the constructor, then this expression would be true. Or if it was randomly generated a 1, then that expression here would be false. Okay? I also have a toString method. So this is a really common method. We can see the type of data that this method returns. This method returns a string, object. And what it does is it goes through and creates a new variable called face name. It says if face equals heads, face name equals HEADS, the string, else face name equals tails, because if face is not heads, remember this face is looking up at its instance data. Is my instance variable face equal to heads, which is 0? Okay? And if it is, then I make face name equal to heads, and then I return face name. Or if it's not equal to 0, if face is 1, then I would return tails, or set face name equal to tails and return tails. All right, that's my explanation of the coin class. I'm going to stop right there, I think. Let me see. This face name variable, it's a local variable. And since it was created inside this method, toString, at the end of the method, that variable is deleted. Okay. I think that's it. Oh, I have to make sure that the type that is returned, which is a string, matches the return type in the method header. And I think that's it. All right. So that's the explanation of my coin class.